Hi friends, today we study free and force vibrations. What is the free vibration and force vibration? In free vibrations, when a string of guitar is plucked, at some point it performs free vibration with its natural frequency. In free vibrations, the body at first is given an initial displacement and the force is then withdrawn. The body starts vibrating and continues the motion on its own. No external force acts on the body further to keep in motion. Then next is the force vibration. The vibrations in a drill machine and washing machine are force vibration. Also the vibration produced in the table top due to tuning fork of two different frequencies are different, as they are force vibration due to two tuning fork of different frequency. In force vibration, an external periodic force is applied on a body whose natural period is different from the period of the force. The body is made to vibrate with a frequency equal to that of the external impressed force. The amplitude of force vibration depends upon the difference between the frequency of external periodic force and the natural frequency of the body. If the difference is small, the amplitude of force vibration is large and vice versa. If the frequencies exactly match, it is termed as a resonance and the amplitude of vibration is maximum. Okay, थोडक्यात सांगायचं म्हणजे फ्री व्हायब्रेशनला एक्सटर्नल फोर्स अप्लाय होत नाही, फोर्स व्हायब्रेशनला एक्सटर्नल फोर्स अप्लाय होतो. ओके, फॉर एक्झाम्पल फ्री व्हायब्रेशन मध्ये आपण गिटार घेऊ शकतो आणि फोर्स व्हायब्रेशन मध्ये ड्रिलिंग मशीन किंवा वॉशिंग मशीन घेऊ शकतो. ओके, नेक्स्ट हार्मोनिक अँड ओव्हरटोन्स. तर हार्मोनिक कशाला म्हणायचं, ओव्हरटोन कशाला म्हणायचं? The term harmonic is used when the frequency of a particular overtone is an integral multiple of the fundamental frequency. In a string and air column, the frequencies of overtones are integral multiple of the fundamental frequency, hence they are termed as harmonic. But all the harmonics may not be present in a given sound, while the overtone are only those multiple of fundamental frequency which are actually present in a given sound. The harmonic may or may not be present in the sound so produced. Okay, harmonic म्हणजे काय? The frequencies of overtones are the integral multiple of fundamental frequency. Okay, harmonics may not be present in a given sound, but overtones are present in a given sound. Okay, next concept is end correction. The end correction कशाला म्हणायचं? The distance between the open end of the pipe and the position of antinode is called the end correction. End correction कशाला म्हणायचं? The distance between open end of the pipe and the position of antinode is called as the end correction. Okay, एखादा पाईप घेतला, त्याला असणार एक क्लोज एंड आणि एक ओपन एंड. क्लोज एंडला नोड प्रोड्यूस होणार आहे, ओपन एंडला अँटी नोड प्रोड्यूस होणार आहे. नोड म्हणजे काय, तर ज्याला फ्रीडम नाहीये, आणि अँटी नोड म्हणजे काय, तर ज्याला फ्रीडम आहे. ओके, आणि जे डिस्टन्स असणार आहे ओपन पाईप मधलं आणि अँटी नोड मधलं त्याला म्हणायचं एंड करेक्शन. ओके, आता फॉर अ पाईप क्लोज ॲट वन एंड आपण आता काय बघणार आहे, लेंथ बघणार आहे. पाईप क्लोज ॲट वन एंड साठी आणि पाईप क्लोज ॲट बोथ एंड साठी. ओके, फर्स्ट पाईप क्लोज ॲट वन एंड. द करेक्टेड लेंथ ऑफ एअर कॉलम कॅपिटल L इज इक्वल टू लेंथ ऑफ एअर कॉलम इन पाईप स्मॉल l प्लस एंड करेक्शन ॲट दी ओपन एंड. दॅट इज capital L is equal to small l plus E, equation number 1. Okay, then second, for a pipe open at both ends. Same here, the corrected length of air column is the capital L is equal to length of air column in pipe small l plus end correction at the open ends. Okay, that is capital L is equal to small l plus twice E. Because of two ends are open, that is the twice E. Okay, because end correction is the distance between the antinode and open end. Okay, then next, vibration of air column in a pipe close at one end. ज्यात आपण काय बघणार आहे, व्हायब्रेशन्स बघणार आहे. ज्या पाईपचा एक एंड काय असणार आहे, क्लोज असणार आहे, एक एंड ओपन असणार आहे. ओके, सी इन दिस डायग्राम. ह्या डायग्राम मध्ये तुम्ही बघू शकता. ओके, कन्सिडर अ लॉन्ग सिलेंड्रिकल ट्यूब क्लोज ॲट वन एंड. इट कन्सिस्ट ऑफ एन एअर कॉलम with rigid boundary at one end. When a vibrating tuning fork is held near the open end of the closed pipe, sound waves are sent by the fork inside the tube. Longitudinal waves traveling along a pipe of finite length are reflected at the ends, as transverse waves are reflected at the fixed end of a string. The phase of the reflected waves depends on whether the end of the pipe is open or closed and how wide the pipe is in compensation to the wavelength of the longitudinal waves, like a sound waves. At the closed end, there is least freedom for motion of air particle. Thus, there must be a node at the closed end. The particle little beyond the open end are most free to vibrate. As a result, an antinode must be found little beyond the open end. The length small l of the pipe and length capital L of the air column are shown separately, but the first mode of vibration of air column close at one end is shown in figure. Okay, आता आपल्याला काय बघायचं तर व्हायब्रेशन ऑफ एअर कॉलम इन अ क्लोज पाईप ॲट वन एंड. ओके, वन सिलेंड्रिकल घेणार आहे आपण, सिलेंड्रिकल ट्यूब घेणार आहे ज्याचा एक एंड काय असणार आहे, क्लोज असणार आहे, एक ओपन असणार आहे. क्लोज एंडला फ्रीडम नसणार आहे, तिथे अँटीनोड प्रोड्यूस होणार आहे. ओपन एंडला फ्रीडम असणार आहे, जिथे अँटीनोड प्रोड्यूस होणार आहे. ओके, आता आपण ट्युनिंग फोर्क घेतल्यानंतर तो रबर पॅडवर हॅमर केल्यानंतर आपण तो पाईपच्या अप्रॉक्सिमेटली वर धरणार आहे. ओके, जेणेकरून तुमचा जो फोर्क आहे तो त्याची वेव्स त्या पाईपमध्ये सेंड करणार आहे. ओके, म्हणजे आता इथे कोणत्या वेव्स ट्रॅव्हलिंग होणार आहे तर लॉन्जिट्युडनल वेव्स ट्रॅव्हलिंग अलॉंग दी traveling along the pipe of finite length. आणि ती जी वेव्स आहे ती काय होणार आहे, रिफ्लेक्ट होणार आहे. These waves are reflected at the ends as transverse waves are reflected at the fixed end of a string. Okay, मी इतक्या वेळेस सांगितलं तुम्हाला जिथे क्लोज एंड असणार आहे तिथे जिथे फ्रीडम नाहीये तिथे काय प्रोड्यूस होणार आहे, नोड. आणि जिथे फ्रीडम असणार आहे तिथे काय प्रोड्यूस होणार आहे, अँटी नोड. ओके, देन दिस इज द सिम्पलेस्ट मोड ऑफ व्हायब्रेशन ऑफ एअर कॉलम क्लोज ॲट वन एंड नोन ॲज द फंडामेंटल मोड. आता आपण काय बघणार आहे, लेंथ ऑफ एअर कॉलम. लेंथ ऑफ एअर कॉलम आपण इथे बघितली किती, ती λ/4. ओके, λ/4 इज द लेंथ ऑफ एअर कॉलम अँड lambda is equal to 4L. Okay, lambda is equal to 4L. Lambda is equal to 4L. Lambda is equal to 4L. Okay, where lambda is the wavelength of fundamental mode of vibration in air column. If n is the fundamental frequency, then we have the relation between the frequency, wavelength and velocity. That is V is equal to n lambda. Equation number 3. Here we get the frequency n is equal to V upon lambda. Put out the value of lambda is equal to 4L. Okay. Then equation becomes n is equal to V upon 4L. Okay. Put out the value of capital L is equal to small l plus e. Means frequency is equal to V upon 4L plus e. Okay. The fundamental frequency is also known as the first harmonic. It is the lowest frequency of vibrations in air column in a pipe closed at one end. The next mode of vibration of air column closed at one end is as shown in figure. Here the air column is made to vibrate in such a way that it contains a node at the closed end, an antinode at the open end, with one more node and antinode in between. If N1 is the frequency and lambda 1 is the wavelength of waves in this mode of vibration in air column, we have the length of air column is capital L is equal to 3 lambda 1 upon 4. Put out the value of lambda 1 is equal to 4L by 3. Okay. Here we get the 4L plus E upon 3. L plus E upon 3. Here we get the N1 is equal to 3N. Okay. This is the third harmonic. It is the first overtone. Remember that the overtones are always number sequential. Okay. See here. L is the 3 lambda 1 by 4. L is the 5 lambda by 2 by 4. Okay. Means the first and second overtones for vibration of air column in a pipe closed at one end, the distance of antinode from the open end of the pipe has been exaggerated. Okay. See here. 2 node, 2 antinode. 3 node, 3 antinode. Okay. Length of air column is the 3 lambda 1 by 4. Length of air column is the 5 lambda by 2 by 4. Okay. The next higher mode of vibration of air column closed at one end is as shown in figure. Here the same air column is made to vibrate in such a way that it contains at the closed end an antinode at open end with 2 more nodes and antinodes in between. If N2 is the frequency and L2 is the wavelength of the waves in this mode of vibration in air column, we have length of air column is the L is equal to 5 lambda 2 by 4. Put out the value of lambda 2 is equal to 4L by 5. Then we get the equation lambda 2 is equal to 4 small l plus e by 5. The velocity this mode is given by V is equal to N2 lambda 2. N2 is equal to V upon lambda 2. Put out the value of lambda 2 is equal to 5V upon 4L. Put out the value of L is equal to L plus E. That is the 5V upon 4L plus E. Means N2 is equal to 5N. This is the frequency, is the fifth harmonic. It is the second overtone. म्हणजे आता आपण इथे काय बघितलं तर व्हायब्रेशन ऑफ एअर कॉलम इन अ पाईप क्लोज ॲट वन एंड. ओके. म्हणजे आता इथे आपल्याला काय भेटलं, N1 is equal to 3N, N2 is equal to 5N. Means this is frequency for the fifth harmonic.